Okay, here we go. We're going to take notes on waves. So we should already have our learning target. Today we're going to be on pages 70 and 71. Our learning target today on page 71 is I can model and describe the different characteristics of waves. All right. So here we go. Wave notes, page 71. Oh man, notes. N-O-T-E-S, not knots. All right, so there are two main types of waves that we are going to be talking about this unit. The first are transverse waves. And transverse waves are where the particles move perpendicular to the direction the wave is traveling. Okay, so particles move perpendicular Okay, so a transverse wave is like this. So each particle is moving up or down as the wave moves left to right. Okay, so water waves are transverse waves. Electromagnetic waves, like light waves, X-rays, infrared radiation, those are transverse waves. So we'll talk a lot more about transverse waves in the coming weeks. The other type of wave that we will talk about are longitudinal waves. And in longitudinal waves, the particles move parallel to the direction the wave is traveling. Parallel. And so sound waves are examples of longitudinal waves. And we will model this a lot, probably next week. Slinky waves also. So you get bunches together and then they spread out. And then they bunch up again and they spread out. So the particles just move back and forth as the whole wave moves left to right. I'm sorry, I'm looking for an animation to show you this so you guys can see the difference. So, in my video, it's going to work here in just a second.
In a longitudinal wave, the disturbance that makes up the wave.
So the longitudinal wave, see there's like a slinky and the particles move back and forth as the wave moves left to right. And then in the transverse wave, this is a weird thing, the particles are moving up and down as the wave moves left to right. So hopefully that makes sense. And again, we'll talk a lot more about this next week. Okay? All right, next what we're going to talk about are just some properties that waves have. So let's write out wave properties. Probably. Oh, and if you guys want some color, we'll use some color for this part. Okay, so the first wave property that we are going to talk about are called peaks. Just like mountain peaks. Peaks, you might also hear them called crests. They are the highest point of a wave. I told you I was going to do color and then I didn't. Peaks or crests. Highest point on the wave. Okay, and then what we're going to do over here on page 70 is we're going to draw a transverse wave, and then we will label all of these parts that we talk about. Okay, so on page 70, I'm going to just draw a big old wave. And we will label this. Okay, so the peaks are these high points. So here's a peak, and here's a peak, here's a peak. Okay? So peaks, the tall points. Next, we're going to talk about the troughs. Trough, everybody say it out loud. Trough. Trough is spelled like this, T-R-O-U-G-H. Trough. It's pronounced trough. Horses and pigs eat out of a trough. And the troughs are the lowest points on the wave. And it's shaped like a trough, like what a pig would eat out of. Trough. Okay, so label your troughs on your wave on page 70. All right, number 3, the third wave property that we're going to talk about is amplitude. And the amplitude of the wave is the distance from your x-axis, your horizontal axis, to a peak or to a trough. And it's measured in meters. And amplitude, when we talk about sound waves, amplitude is directly related to volume. So if you have an electric guitar, you plug it into an amplifier to increase the amplitude, to increase the volume of your sound. So amplitude is the distance from the x-axis to a peak, but it can also be measured from the axis to a trough. Okay. All right, next is going to be wavelength. And the wavelength is going to be the distance from peak to peak or from trough to trough. Okay. distance from peak to peak, or trough to trough. Okay, so on our picture, sorry, distance from peak to peak, or trough to trough. We'll label it over here on our picture. So from here to here is wavelength. But it could also be measured from trough to trough. All right. Next, we're almost done. Okay. Move my camera a little bit. I'm sorry. Causing disasters over here, guys. Okay. Next, we're going to talk about frequency. The frequency of a wave is the number of waves per second. You can kind of imagine frequency like if you're standing on a beach and you're counting how many waves come in from the ocean, right? You're counting how frequently the waves hit. Same with other waves. Frequency, the number of complete waves per second. And our units for frequency are going to be hertz. Measured in hertz. And we'll abbreviate it HZ. Okay, so those are the 5 main characteristics of waves that we are going to continue to talk about throughout this unit. The last thing that I think I want to talk about with you guys today we're not going to talk about it. There's 3 types of waves that we're going to go into more detail about. Sound waves, electromagnetic waves, and seismic waves. If there's enough time in class, Mr. R, I'm going to leave it up to you. If you guys think you have enough time to finish notes, you could, or Mr. R, just let me know if you didn't get this far, and we will do these notes next time. No big deal. Okay, but good job today, guys. Thank you so much, and I will see you all next class.